stick with like I'm not teaching anything brand new, but different ways of looking at it. So if this normal CDF inverse norm is kind of driving you crazy, we're kind of sticking with that, right? Like we're going to use that quite a bit. So here we go. Standard normal distribution. And this is where z-scores come back. Okay, this is our topic there. And we can say that any normal distribution I will make a very big distinction. There is something like standard normal distribution, and then there's just a normal distribution, okay? And any normal distribution can be converted into a standard normal distribution. Characteristics. The values along the bottom are called z-scores. Z-scores tell us how many standard deviations a value is from the mean. Negative z-score means value is to the left of mean. Positive z-score, value is to the right of mean. Z-scores are especially useful when comparing values in different data sets. I'll give you two formulas that you should definitely have on your study sheet. The z-score is found by taking a data point, subtracting that data point by the average of that set, all of that divided by standard deviation. And I will put in like brackets on top because that needs to happen. Okay. X is data point, is the average, right? standard deviation. If you know what they mean, you don't necessarily need to write down the when should you be using the formula and when using your calculator. The answer is it's up to you, but this one is easier to use most of the time. Okay, when using a calculator, you need to know exactly what's happening and not mix things up. And from this, you can also figure out the actual value, right, by just taking the z-score, multiplying that by the standard deviation, and adding the average to it. Used to find the actual score / data point. So basically, if you have the z-score, the standard deviation, and the average, and they're asking you, like, what's that weight? Allow me for 1 second. I'm going to go back to that AC that you got to keep, okay? If you, this one, for example, you knew your average, you knew the standard deviation, and you knew the z-score. So you could have used that formula, right? Or, right, you would have taken, oh, I need that formula myself. I take the z-score, which is negative 2.7. I multiply it by the standard deviation, which is 0.1. You should write this down too in there, why not? Plus the average, which is 8. And your calculator is really good at doing this. It should have no issues you typing it in one shot. You go negative 2.7 times 0.1 plus 8. I hope it's 773. Phew. It is. Otherwise, everything would have been wrong, right? So it's the same. We essentially are doing the same way. One is using your calculator, just using normal CDF inverse norm. The other one is using the formula. Okay. So there it is. That's how I use that formula. Let's do an example here. Will this fit on this little chunk here? No, I will start a new page. I know it's a little bit of a waste, but I want the whole thing on one page, so I will go back here. What is my time? Okay, I still have a little bit. So z-scores to compare different data points. Okay. Rose and Angel. Sorry, Angel. These are actually twins, Rose and Angel. Rose and Angel are twins. They both took APMR, actually happened, with different teachers. Okay. Results, right, are summarized below. So I'm just going to give you a table to make things easier. So let's say we have, I'm going to leave a little bit of space. Rose is here, Angel is here. We're going to have 3 columns. So we're going to have the mean, the standard deviation, and their actual scores. Okay, so Rose, in her class, the average was 73. The standard deviation of that class was 6%. And Rose scored 67 overall. Okay. Angel, the average of that class was 86%. And the standard deviation was 5. Her actual score was 78%. So Angel claimed, right? Angel is saying, hey, I scored 78, you 67, I did better than you, right? And the answer is they're in different classes, right? So this would be class A, and this would be class B, so to speak, right? So they're different classes. You can't do that. You can't do that with different classes. You know that, right? Every teacher has a different style. Therefore, the class will have a different average. Everything will be different, okay? So what you need to do here is find the z-score. Who did better overall? So we're going to find a z-score. For each. Okay. So we're going to go, we'll do rows here. The z-score for rows, you got to use that formula that I just gave you, which is her actual score. I know it's all percent, that doesn't matter. Minus the average, which is 73%, divided by the standard deviation, which is 6%. And then I will calculate Angel's z-score right next to it. And so Angel scored 78% minus the average divided by the standard deviation. I will put brackets on the top like that. So let's go ahead and find that out. We can probably do this ourselves, right? This is minus 6 divided by 6 would just be minus 1. The z-score never has units, okay? No units. Okay? The z-score for Angel, we have 78 minus 86, right? That's negative 8. And then we go negative 8 divided by 5. That's negative 1.6. Did either one of them, just by looking at the z-score, did either one of them do great compared to the rest of the class? There's the average, and if your score is in the minus, anything in the minus, you're below the average, right? So that's worth noting. Note both have a negative z-score, therefore did not do so good. Below average. Okay, but who did better between the two? Rose, right? Rose isn't as far from the mean as Angel is, right? And in this case, you don't want, if you're negative 1.6 versus minus 1, right? Angel did better. Rose, sorry. Rose did better than Angel because she has a higher z-score, a greater z-score. The greater your z-score, the better you will have done when you're comparing scores in particular, right? So let's just, I just want to give you a visual here. Real quick, this is what's happening here. This is Rose. Rose is normal, so let's try to fit them in side by side. So 1, 2, 3, 1, 2, 3. There's the mean. 1, 2, 3, 1, 2, 3. So this is Angel. Angel had there was an average of 86%. The average for Rose is 73%. Okay. And so what happened here is, if you were to draw the normal curves for both classes, they would look very much the same, except for they have different averages, right? You can tell that Rose with a 67, 67 is right here, right? Rose would be located right there on her class, and the other one has 5%, so this is 81. This is 76. So 78, Angel would be right about there. Okay. So what we're doing is, when we're finding the z-scores, we're putting them both in a standardized curve, which is 1, 1, 2, 3, -1, -2, -3. So you're transferring both of them into a standard normal distribution. Standard normal distribution. Let me try to help you here. It's almost like one is saying, you're working with miles, and another one is working with meters, and you're standardizing and making everything in centimeters, right? That would be a way of, let's put them both now on the same plane. So when you have your standard normal distribution, you can now say, hey, let's look at the z-scores, and we put Rose right here, and Angel would be right there, right? So we're transferring the information, right, into a standard normal distribution. So, and these are z-scores, right? And you can write them at the same time when you're doing a curve, especially if you're only dealing with one data set, okay? Here's what I want you to work on, because I realized that 264 will now probably make more sense than before. That was my bad. I should have known that. Oh yeah. Look, hold on. Before you leave, I will post the I'll post the homework, but page 264, 1 to 11 again. But watch this now. If you did that already, the workbook. page, I have this written down, so just give me 1 second. 14 to 15, as well as 16. Okay?